Hello there, and welcome to Smart Student TV, the only channel where academic and professional prowess is nurtured right from the comfort of your living room. Whether you are a student striving for excellence, a professional looking to sharpen your skills, or simply a lifelong learner, you are in the right place. In today's tutorial, we dive into another very crucial topic: personal protective equipment, PPE. Our focus will primarily be on their application in a laboratory workplace. This comprehensive tutorial will cover everything you need to know about PPEs, their importance, types, proper usage, and maintenance. Let's begin. What are PPEs? Personal protective equipment, PPE, refers to specialized clothing or equipment worn by an individual to minimize exposure to hazards that cause serious workplace injuries or illnesses. These hazards may stem from contact with chemical, biological, physical, electrical, mechanical, or radiological dangers. PPEs act as a barrier between the wearer and potential harmful substances or environments. However, it is important to understand that while PPEs provide a significant layer of protection, they do not eliminate hazards from the environment. Instead, they offer a barrier between the user and the hazard, serving as the last line of defense when other safety measures fail. The extent of protection varies with the quality, proper usage, and maintenance of PPE. Misuse or reliance on PPE without addressing the primary hazard can lead to accidents. PPEs are just part of a broader spectrum of hazard control methods. Before resorting to PPE, consider implementing the following hierarchy of controls. 1. Elimination. Remove the hazard entirely from the environment. 2. Substitution. Replace hazardous materials or processes with less dangerous alternatives. 3. Engineering controls. Use equipment or processes to isolate people from the hazard, e.g., fume hoods, ventilation systems. 4. Administrative controls. Establish policies, training, and procedures to minimize exposure, e.g., rotating staff to limit exposure time. 5. PPE is often employed when these methods are insufficient or impractical, making it a critical but secondary line of defense. Why are PPEs important? 1. Protection from hazards. PPEs protect against injuries or illnesses caused by exposure to hazardous substances or conditions. 2. Compliance with regulations. Many workplace safety regulations mandate the use of PPEs to ensure a safe working environment. 3. Enhancing productivity. A safe and secure worker is more productive and focused on their tasks. 4. Preventing contamination. PPEs prevent cross-contamination, especially in sensitive environments like laboratories. Why do people not use PPEs as required? 1. Lack of awareness. Some individuals are unaware of the hazards or the importance of PPE. 2. Discomfort. Poorly designed or ill-fitting PPE can be uncomfortable to wear. 3. Cost. High-quality PPE may be considered expensive. 4. Negligence. A false sense of security may lead some to ignore PPE guidelines. 5. Inadequate training. Improper use often results from insufficient training. Where and when do we use PPEs? PPEs are used in environments where hazards are present, such as 1. Laboratories handling chemicals, biological agents, or radioactive materials. 2. Industrial settings involving machinery or harmful materials. 3. Healthcare settings where exposure to infectious agents is possible. 4. Construction sites with physical hazards like falling objects or sharp tools. How do we use PPEs? 1. Choose the correct PPE based on the hazard assessment. 2. Ensure PPE is in good condition before use. 3. Properly wear PPE according to the manufacturer's instructions. 4. Remove PPE carefully to avoid contamination. 5. Regularly clean and store PPE appropriately. Qualities of good PPEs. Good PPEs should 1. Provide adequate protection against the particular hazards for which they are designed. 2. Be reasonably comfortable when worn under the designated conditions. 3. Fit comfortably without interfering with the movements or vision of the wearer. 4. Be durable. 5. Be affordable. 6. Be capable of being disinfected. 7. Be easily cleanable. 8. Be kept clean and in good repair. 9. Compliance. Meets regulatory standards. Types of PPEs and their applications in laboratories. Personal protective equipment, PPE, encompasses various items designed to safeguard different parts of the body from specific hazards. Each type of PPE is tailored to address unique challenges in the laboratory environment. Below is a detailed overview. 1. Nose and mouth protection. Nose and mouth protection prevents inhalation of harmful aerosols, fumes, and pathogens. Respirators, for instance, protect against insufficient oxygen environments, harmful dusts, fogs, smokes, mists, gases, vapors, and sprays which can cause cancer, lung impairment, diseases, or death. Respiratory protectors may include use of dust mask, face masks, and even use of fume hoods or chambers. There are many types of respirators and masks available, and the different types offer very different levels of respiratory protection. They are used in laboratories when handling chemicals, infectious agents, or dusty environments. They should 1. Provide high filtration efficiency. 2. Provide comfortable fit. 3. Be made from durable materials. 2. Face protection. Are used when working with large volumes of hazardous materials, or for protection from splash to the face or flying particles. Face shields must be used in conjunction with safety glasses. They are worn over the face, usually attached to a helmet or a headband. They should 1. Have clear visibility. 2. Be made from sturdy material. 3. Have anti-fog properties. 3. Eye protection. Eye protection prevents damage from splashes, debris, or bright lights. Examples include safety goggles, spectacles, contact lenses, etc. Contact lenses, for instance, may be worn in the laboratory, but do not offer any protection from chemical contact. If a contact lens becomes contaminated with a hazardous chemical, remove the lens immediately and rinse the eyes using an eye wash. Contact lenses that have been contaminated with a chemical must be discarded. Safety glasses are worn whenever there is the possibility of objects striking the eye, such as particles, glass, or metal shards. Safety glasses do not provide adequate protection from significant chemical splashes. They do not seal to the face, resulting in gaps at the top, bottom, and sides, where chemicals may seep through. They are also not appropriate for dusts and powders, which can get by the glasses in ways similar to those described above. They are securely worn over the eyes with adjustable straps if necessary. They are used during chemical handling, centrifugation, or UV light exposure. They should 1. Be scratch resistance. 2. Provide adjustable fit. 3. Be impact resistance. 4. Hand protection. Gloves provide covering for the hand. They protect and comfort hands against cold or heat, damage by friction, abrasion, or chemicals, and disease, or in turn to provide a guard for what a bare hand should not touch. Based on their usability, gloves can be classified into disposable and non-disposable gloves. Examples: nitrile, latex, heat-resistant gloves. They are worn snugly on hands, ensuring no gaps. They are used during chemical handling, sterilization processes, or heat-related experiments. They should 1. Be chemically and microbiologically resistant. 2. Have high dexterity. 3. Be tear resistance. 5. Foot protection. Footwear prevents injuries from chemical spills or falling objects. Examples include safety boots, gumboots, and shoe covers. They are worn securely to cover feet completely. They are used in laboratories, clean room environments, construction sites, etc. They should 1. Be slip resistance. 2. Have high chemical impermeability. 3. Be durability. 6. Head protection. Head protective gears include hats, caps, and helmets. They protect the wearer's head from impact and penetration by falling or flying objects and from high-voltage shock and burn. They are used in construction sites, during fieldwork, or in labs with overhead hazards or risk of falling objects. They should 1. Be lightweight. 2. Have high shock absorption. 3. Provide adjustable fit. 7. Body protection. They protect the torso and body from splashes, heat, or contaminants. They include lab coats, dust coats, aprons, overalls, surgical or medical gowns. They are worn over regular clothing. Some provide full body coverage. Lab coats are appropriate for minor chemical splashes and solids contamination. Aprons are best for protection from corrosive or irritating liquids. Surgical disposable gowns may be useful in clinical procedures or when cleaning and decontamination of reusable clothing is difficult. Overalls can be used to protect the clothing from spatters and spills. They are used during chemical synthesis, sterilization, or handling infectious agents. They should 1. Provide high chemical resistance. 2. Offer flame retardants. 3. Made of breathable materials. 8. Hearing protection. They protects against harmful noise levels. Examples include ear plugs, ear muffs. They are inserted into the ear canal or worn over the ears. Used in noisy environments with machinery or ultrasonic equipment. They should 1. Have high noise reduction efficiency. 2. Be comfort even during prolonged use. 3. Be hygienically designed. 9. Vibration protection. They reduces the effects of prolonged vibration exposure. Examples include anti-vibration gloves. They are worn while handling vibrating tools or equipment. They can be used in noisy construction sites or in laboratories when using centrifuges or sonicators. They should 1. Have high shock absorption. 2. Be ergonomically designed. 3. Made from durable materials. 10. Heat and cold protection. They protects against extreme temperature exposure. Example include thermal gloves, insulated boots, heat-resistant suits. They are worn to cover and insulate body parts. Used when handling cryogenic materials or working near furnaces. They should 1. Provide high insulating properties. 2. Provide resistance to temperature extremes. 3. Be comfortable and flexible. 11. Fume chamber. Fume cupboards are used widely in laboratories. A fume chamber are often considered as a PPE since it protects the laboratory user from exposure to hazards caused due to fumes. They are designed to capture and remove airborne hazardous substances generated during laboratory experiments, e.g. gases, vapors, aerosols, and particulates or dust. 12. Biological Safety Cabinet. Biological Safety Cabinets, BSC, are enclosed workstations intended to serve as a barrier to protect individuals working with biohazardous materials. Laboratory procedures that could create airborne biohazards should always be performed in a BSC as it protects laboratory workers and the environment from aerosols or droplets that could spread biohazardous material. There are 3 general types of biosafety cabinets available. Class 1, 2, 3, each with specific performance characteristics and applications. Care of PPEs. 1. Regularly clean PPE to maintain hygiene and functionality. 2. Store in a clean, dry place away from direct sunlight and chemicals. 3. Check for wear and tear before and after each use. 4. Repair or replace damaged or broken PPE. Causes leading to deterioration of PPEs. 1. Improper storage, exposure to sunlight, moisture, or chemicals. 2. Frequent use, wear and tear from repeated use. 3. Poor maintenance, lack of regular cleaning and inspection. 4. Chemical exposure, direct contact with corrosive substances. Disposal of PPEs. 1. Segregate or separate contaminated PPEs from regular waste. 2. Decontaminate reusable PPEs before disposal. 3. Adhere to local guidelines for hazardous waste disposal. 4. Safely incinerate biohazardous PPEs. Personal protective equipment is a cornerstone of safety in laboratory settings. Proper understanding, use, and maintenance are vital to ensure maximum protection against hazards. By prioritizing safety and adhering to PPE guidelines, we create a safer, more productive working environment for everyone. Thank you for joining us on Smart Student TV for this essential tutorial. Remember